Hello, class. So this is going to be the first video in chapter 2. As I mentioned, we're going to be skipping section 1 for now. So if you're following in the book, this is chapter 2, section 2. So again, skipping section 1 for now. I'm going to cover it just a little bit later. So in this section, we talk about differential equations of a certain form, and differential equations of this form are going to be called separable. So what are separable differential equations? Let me go back to this example. This is an example of a separable differential equation. Now, I haven't defined what it is yet, and I will in a moment, just bear with me. Now, for this problem, or a differential equation of this form, what was the process? Divide both sides by this, and then integrate. One side with respect to y, the other side with respect to the independent variable, in this case, x. That was the process. And if I write the steps for that, basically divide both sides. So dy dx divided by by plus c dx equals integral of 1 dx. Then if you remember, this inside here, the dy dx times dx just becomes dy. So it just becomes the integral of dy over by plus c. So like I mentioned, integrate the left-hand side with respect to y, integrate the right-hand side with respect to x. And this was the process, right? And then solve for y. Now, let's do another example. This one is going to be a little bit more complicated, but really it's going to be very similar. So find the general solution for the ODE dy dx equals 4 times y over x. Now notice that this differential equation does not have this form. It does not have this form because there's not only a constant multiplying y, there's also 1 over x. So there's not a constant multiplying y, it's actually a function of x, 4 divided by x. So this wouldn't follow this method here. It wouldn't follow this format or this form. So how do we find the general solution? How do we go about solving this differential equation? Well, actually, you do the same thing. What you're going to do is move everything that involves the term y to the other side. So what I'm going to do is divide both sides by, okay, so I have this term involving y here. So I'm going to divide both sides by y. And what's left on the other side is just things involving the independent variable or constants. Now that we have it like this, we're just going to integrate both sides. And it should work. Why should it work? Because, again, when we integrate both sides with respect to x, remember, always integrate with respect to the independent variable. Again, dy dx times dx becomes dy. So this is just dy over y equals the integral of 4 over x dx. Here, we know how to integrate both sides. So if we integrate the left-hand side, we get natural log of absolute value of y plus some constant equals 4, natural log of the absolute value of x, plus some constant. Combine both constants into a single constant c. Afterwards, again, we're trying to solve for y at this point, so just take the exponential of both sides. Take plus or minus of both sides. Let me write implies here. Take the plus or minus on the other side to get rid of the absolute value. So plus or minus e to the 4 ln absolute value of x plus c. And now we have our solution. Again, you can leave it like this if you want. This is perfectly fine for me. So if you see, we started with something that didn't have this form, but we were still able to do the same process. The only thing that was different is we didn't divide by everything. All we did is divide by everything that's just y. So basically, the goal of this is, can you move everything involving y to one side of the equation, so including derivatives, so everything involving y, to one side, instead of equal to everything involving x or constants, where x is the independent variable. As long as you can do that, you can do this process. Now, this only works for first order ODEs. Notice I'm not saying anything about linear. These differential equations don't have to be linear. As long as you have a first order ODE in which you can do this, have everything involving y on one side and everything involving x on the other side, then this process is going to work. You can just integrate both sides. Okay. Now, mathematically, when can I do this? That's the question we want to answer. Is there a way that I can determine that it is possible to write everything, the differential equation, like this? Okay. So let's see another example and see if we can see what the pattern is. How does our differential equation have to look like for us to be able to rewrite it in this form? Let's find the general solution for this ODE. Again, we're only going to be working with first order ones. This process is only going to work for first order ODEs. So I have dy dx equals e to the 3x plus 2y. Again, our goal is, can I move everything involving y to the same side and leave everything involving x and constants on the other side? Can I do that? Well, as it is, it's not maybe entirely clear whether I can or not. But using properties of exponents, I can rewrite this as e to the 3x times e to the 2y. So I've done this process before, right, where adding exponents is the same as multiplying with the same base. Now, if I have it like this, it's a little bit more obvious that I can move everything involving y to the same side of the equation. Why? Because now I can divide both sides by e to the 2y. I get dy dx divided by e to the 2y equals e to the 3x. And now this is the form that we want. We have everything involving x on one side by itself, and then everything involving y on one side. Now, let me make a note here. If you see, every time I move things to the other side, I do it by dividing. And it's the same thing that we did when we were working with differential equations of this form. I didn't subtract by to the other side. I divided by everything involving y. That's the other thing you have to be careful for. You want to be able to get this, a differential equation in this form, only by dividing. That's the only operation you're allowed to do. If you do other things like subtracting and stuff like that, it won't work out. This algorithm doesn't work. So here, I was able to move everything involving y to one side by dividing. So use only division. So this works. I can move everything to one side involving y by dividing. Everything on the other side is just x or constant. So I can just integrate both sides. So here I'm going to skip the work. So I mentioned this in previous videos, that you can go directly from here, or actually, I would say, yeah, you can just go directly from here to the integral of the left-hand side with respect to y equals the integral of the other side with respect to the x, the independent variable. Now, we can integrate both sides easily. First, let me rewrite this as, just so it's easier, e to the negative 2y. Remember, you can move something on the bottom of a fraction to the top, or vice versa, by making the exponent negative. Here, I'm just going to go ahead and integrate immediately. This is 1/3 e to the 3x plus some constant. Then the left-hand side is going to be basically the same rule for integrating. Some constant. Again, we're trying to solve for y. So move everything not involving y to the other side. So we combine the constants first. to a new arbitrary constant c, multiply everything by -2, -2 times an arbitrary constant is again an arbitrary constant. We want to get rid of the exponential, so take the natural log of both sides. Finally, divide everything by -2. And that's the general solution. Okay, so what is it that we are supposed to be able to do? Again, reviewing. Given a first order differential equation, can you get it in the form where you have everything involving y on one side of the equation, everything not involving y, which is just going to be x and constants, on the other side, and can you do this only by dividing? Now that we've seen a couple examples, what is it that what determines whether you can do this or not? Well, it's actually very simple, and that's our first definition. A first order differential equation of the form dy dx equals h of y times g of x is said to be separable. Now, why does this work? Well, you need a differential equation that looks like this, or that is separable. Why? Because, well, first of all, let me remind you what this means. Remember, I said before, when I was talking in the previous videos about notation, when you see something like h of y, that just means some expression involving y's. Right? You don't know what that expression is. It could be just y. It could be something complicated like y squared plus sine of y, etc. It doesn't matter. It just means it could also include constants. It doesn't matter. It just means h of y has to be an expression only involving y or constants. Similarly for g of x, we want g of x to be an expression only involving x or constants. So again, it could be as simple as x, it could be as complicated as ln of x squared divided by x minus 3. It doesn't matter how complicated it is, as long as it only has x's and constants, you're good. So this is the condition that we need. Given a differential equation, can you write it as dy dx equals some expression involving only y's or constants times some expression involving only x or constants? Why is this the condition we need for us to be able to do that process that I showed you in the previous two examples? Well, if you can do this, then you can just divide both sides by h of y. And then from this, just integrate. Just integrate both sides. The left-hand side with respect to y, the right-hand side with respect to x. So this is the condition that we need. We need our differential equation to be separable for us to use this algorithm. Now, it's not always obvious that a differential equation is separable. For example, we looked at this differential equation. Maybe it's not obvious that this actually is separable, that this looks like something involving only x and constants times something involving only y's and constants. But using properties of exponents, we saw that it is the case because we can write this as e to the 3x times e to the 3y. And then this here would be our expression involving x, we call g of x, and this would be our expression involving y. And then all we did, divide both sides by h of y and integrate. So that's what a separable differential equation is. And how do you solve them? Just when you write it in this form, h of y times g of x, divide by h of y on both sides, and then integrate. So we're going to do one more example here, but I'm going to do it in the next video just so this video isn't too long.